to their RC aircraft. And one of the most popular ones is called a multi-copter. And what that means is it's got multiple blades. This one has 3 blades on it. You could have a helicopter with a single blade. You could have a quadcopter with 4. Quadcopters are very popular. It's a little odd to see a tricopter. But that's what this is called, a tricopter. So we started adding GoPros. They were pretty cheap, so we started adding those to our RC aircraft. And then we started figuring out how to transmit video. There's a video transmitter back here. It works just like a television broadcast. It broadcasts through the air from this little tiny antenna here, and then it goes into this antenna here, into a receiver, and then it gets projected onto the TV, so you guys can see all yourselves on there, obviously. You also notice there's some other fancy things going on there, like you see that number 10 over here and 8. It's giving me data. It's shorter. It's a barometer. There's a barometer on there. So this is a heads-up display like you'd have in like a fighter jet. We're indoors right now, so it's not acquiring satellites. It has a GPS receiver right here. And this board here is displaying all that overlay. So the video gets sent to that board, then it overlays all this data from the sensors like the barometer, voltage of batteries, the GPS coordinate positions. It can tell you how far away you are from home when you're outside, so you can get back if you get lost, things like that. There's all kinds of advanced stuff you can do with these on-screen displays, they're called. Also, you have a traditional radio receiver here, or a radio control receiver. Normally, with a normal plane where you just fly it line of sight, that's all you would use. But here, we send all that information to this computer here. You can see it's got an LCD on it. It says safe right now. It's just that means the whole tricopter is disarmed. I have to go through a certain action with the sticks before it arms. And then it also has gyros and accelerometers on it. It has 3 of each. X, Y, and Z accelerometers, and then pitch, yaw, and roll is for the gyros. And that helps stabilize the flight of this. It's possible to fly one of these without the computer, but it's very difficult. You have to be very skilled and fast on the sticks, so that smooths that out. Especially that I'm going to fly this indoors here. I want to use the stabilization in there. So I actually have a mode where I can switch on my radio that stabilizes it, makes it very easy to fly, and it automatically levels it with those gyros. Okay, does anybody have any questions? Does that make sense how you have the video? My batteries just finished charging for the next flight if I do one.
Why a barometer? Height.
Oh, height, yeah, so you know how high or up you are. I guess it's you kind of know when you're getting close to the ground now when you have a video feed.
What kind of weapons can we put on this?
You can put bottle rockets probably.
What's the price? How much does it cost for the whole system?
This one,
Average.
let's see here. Well, you can get as low as about $150 with the one that has a video feed to like your iPhone.
Oh, brilliant.
So it's pretty cheap. And then you can go all the way up to $30,000 for something that has like a professional camera hanging off the bottom. It has automatic gyro stabilization, and it's a pretty large craft, like an octocopter with 8 blades. I built this one, yeah, so that's a good question. So I built this one. You can see a lot of it's laser cut. I also etched the
Well done.
Hackerspace logo on there. This is Delrin down here on the bottom. This plastic, so it's partially Delrin, partially wood. So I used wood where it's in tension, and where it's in compression, it's wood, and where it's in tension, it's this Delrin. Actually, this Delrin plate that I added here is a little too heavy. I need to lighten it up a little bit. Then the sticks, the arms, are just basic craft sticks, these square sticks. I did that so that if they break, I can just make new ones. So it's designed to break on the arms, and all the rest of the components should stay intact.
Did you try your flight time, and what is your flight time?
The flight time is about 6 minutes. This one's a little bit overloaded. It's a kind of an older setup. I have some older motors. This one's it's about 4 or 5 years old now. So I've been flying it for quite a while. So it's pretty short. 6 minutes and that's it. Yeah. You can get up to a half hour, and now they're starting to get about an hour out of some of these multi-copters because they're really getting good at making it efficient and the right size batteries. This one is a Spectrum controller. So this is a brand.
I mean the board.
Oh, the board? Yep, the board is based on Arduino And then they started making custom boards. So it's an at-melt chip. I think it's got like 32 kilobytes of memory on it. It's pretty small computer, but it has very fast updates to all the motors, and also on a tricopter, in order to turn this way, you have to be able to turn the tail. So this tail has a servo on it, and it'll actually tilt it.
Nice.
That allows me to do rotation.
Well done.
Left and right is just changing the speeds of the two front propellers, and front and back is, if you want to go backwards, you increase the speed of these two up here and decrease it down here, and then the opposite for going forward. And that's essentially how it flies. So I'll answer some more detailed questions afterwards.